Okay, so in this figure, you see two intersecting what? Lines. There are two intersecting lines, and they make how many angles? There are 4 angles there, right? There are 4. And A and B, how are they related to each other? What's the angle relationship there? They're opposite each other. And they're equal to each other. Well, no. They're equal to each other because they're across a... no, I thought you were going to say they're equal to each other. What you meant was they're equal to each other. Yes, Danny, perfect. Okay, so A and B are equal to each other because they are, starts with a V, what kind of angles? Starts with a V. Vertical angles. They are vertical angles. So they are vertical angles, so they are equal to each other. Now, these two add up to 180, Luis, because they make a, Micah, they make a line, and a line is 180 degrees. These two angles also are vertical angles, which means they also must be equal to each other. So remember, if they're across from each other, they're congruent, and if they are next to each other, then they're supplementary, which means they add up to 180 because they make a line. So if I wanted to solve for x here, these two angles are vertical, so what would I do? Would I add them up to 180 or would I make them equal? Make them equal. Good. So I'm going to make them equal, and I'm going to say 3x plus 10 is equal to 5x minus 8. And then what do I do? Yeah, put my x's together. So which one do I want to move? The 3, because then it'll stay positive. So I'll subtract 3x, and then I subtract it over here. What do I do with this 8? Move it over. So I add 8, and then I add it to the 10. Okay, so that gives me what over here? 18 equals, good. So then how do I finish? Perfect. There you go. X equals 9. So that's the first part, x equals 9. And then I want to find the measure of angle A and B. So I need to find the measure of this. But before I can do that, yeah, I can do this, which is 3 times 9 is 27, plus 10 is 37. So this one is 37 degrees. So then how could I find A or B? Subtract Danny from 180, because they are supplementary angles. They make a straight line, like Micah said. So I'm going to subtract from 180. So I'm going to do 180 minus 37, which gives me 143. Okay? So that right there kind of sums up everything we did pretty much before the break. We've got vertical angles. We've got lines intersecting to form angles. We've got supplementary angles. And pretty much the only things angles are going to do is either be equal or add up to 180. If they add up to 90, what are they called? Starts with a C. Complementary. Very good. Like I'm giving you a compliment, but the other kind of compliment, right? So complementary. Very good. Okay? So today, today what we're going to talk about is probably what you expect when you think of geometry. So whenever I said at the beginning of the year, like how many of you guys have talked about geometry or done geometry before, and somebody said, inevitably somebody always says area and perimeter. So that's what we're talking about now. So we're going to move forward talking about area and perimeter, and today we're going to talk about the area and perimeter of rectangles and squares and triangles, and then we're going to talk about circumference and area of circles. All right, so we're going to start with rectangles and squares. So when we talk about perimeter and area, what's the difference? What is the perimeter versus the area? Luis? Okay, perfect. Perimeter is like the outline, good. Area is the inside, exactly. The way that I think about it is perimeter is like the baseboard on a floor and area is like the carpet. Like area covers everything in the middle, okay? So typically when you're finding perimeter, how do you find it? Add up all the sides. Exactly. Add up all the outsides. So in this triangle, if you were doing perimeter, would the dotted line be included? No. Very good. Why not? Because it's inside the triangle. Perfect. Okay. So to find the area of a rectangle, let's say that this were 5 and this were 10. Sorry, to find the perimeter. How would you find the perimeter of that rectangle? Which gives me what? 30. Perfect. So the perimeter of that rectangle would be 30. What about the area? How would you find all the space inside? 5 times 10. You typically multiply, right? You're going to multiply. So the area, you do length times width, which would be 5 times 10, which is 50. Good. Okay, so length times width. Why do we use a cursive L? Yeah, if you do a not cursive L, it looks like a 1, okay? If you write it not in cursive, it's not wrong. I'm just going to put it in cursive, that's why. Because if I write it like this, it looks like 1 times W.
Why didn't you just do a capital L?
Because, oh, why didn't I? Because what does capital L mean?
I don't know.
Not length. Think science. Think soda. No, liter. Yeah, capital L stands for liters. So you don't want to use a capital L because we use it to stand for liters. That's a good question, though. Okay, so for a square, if this were 2, do you have enough information here to find the area and perimeter? Yes. Why?
A square is equal.
A square means all the sides are equal. So the perimeter here would be what? 8, because we would do 2 plus 2 plus 2 plus 2, which is 8. What about area? Area would still be length times width, which would be 4. All right, so area is still length times width when we're talking about a square. All right, what would be the perimeter of this triangle? What would be the perimeter of this triangle?
24.
Why?
Because I had wrong side.
Which sides?
12, 5, and 6.
And again, you didn't include the 6. How come, Micah?
Because technically, since it's dotted, it's not even there.
Okay, yes. Good. Okay, technically, if it's dotted, it's like we talked about before, that's an invisible line, so it's not even really there. But also, it's on the inside of the figure. Okay, so you wouldn't use it because it's on the inside. Perimeter, again, is like if you're putting up a fence around the outside of something, you wouldn't include whatever's on the inside. All right, how do you find the area of a triangle? Martin. How do you find the area of a triangle? Madeline, what are you thinking? Yes, it is area equals half base height, and sometimes we write it differently. We can either say area equals 1/2 base times height, or even though you shouldn't be, because some people really are afraid of fractions, you shouldn't be, but if you are one of those people, you can also think about it as area equals base times height divided by 2. Those are the same thing. So taking half of something and dividing it by 2 are exactly the same thing. Why? Why is it base times height divided by 2?
Oh, because it's half of the base.
But why?
Would it be the 6?
You do need the 6. Think about it like this. If this is our rectangle, and the base is 10, and the height is 12, how would you find the area? Multiply them. And that would give you what? 120, right? So that would be area equals 120. Okay. How could I cut this to make it into a triangle?
Oh, you
Cut it in half. Exactly. What do I do to turn that into a triangle? I take this area and I cut it into 2 pieces, which is why base times height divided by 2 gives us a triangle, because every triangle is really just half of another rectangle, okay? So now it's just about, well, what's the base and what's the height? Well, where's the base of this triangle? 12, because base means it's on the bottom, right? But then which one's the height? And Madeline said we have to use why the 6? Why not the 5 or the 7? Exactly. Here's my triangle. That's how tall it actually is. 5 and 7 are what kind of lines? Slanted. Can a height be slanted? No. Okay, so area here would be area equals 12 times 6 divided by 2. Or you could say half of 12 times 6. And this might be a little bit easier because you can just do what's half of 12? 6. And 6 times 6 is 36. So the area of that would be 36. This would give you the same thing. 12 times 6 is 72. Half of 72 is 36. Okay, so either way it's the same thing. Just depends on what you prefer. All right, so these are formulas for the area and perimeter of a figure. There aren't really formulas for perimeters, just add up all the sides. Okay? You will need to know these, but typically on any big test or quiz, I will give you a formula sheet. So if you don't have them memorized, that's okay. You just basically need to know, if I give you this, you need to know what B is and what H is. All right? So again, the really important thing here is that height has to be a straight up and down line. So in this case, it has to be the 6. All right, over here, the height of this triangle would still be 12. It doesn't have to be inside it. That's a straight up and down line, so that 12 would count as the height. Okay. Where would the base and height be of this triangle? Would we have to draw the height, or is it in here now? Where would you have to draw it? In the middle, down from here. So this would be the height, and then where's the base? At the bottom. Okay. What about this one? Is the height there? Do we have to draw it? Draw it. Okay, same thing. We need a dotted line, and then where's the base? Same thing on the bottom. All right, what about this one?
It already has it.
It already has the height. Why?
Because it's a straight line.
This is straight already, so that one's the height, and then the base is right here. Okay? So the difference is that this one already has the straight line, so that counts as the height, and then this is the base. I will tell you that no matter what, no matter how many times I repeat myself, people will always forget to divide by 2 for a triangle. So just don't. Try to remember. Okay. How would I find the perimeter? Actually, skip this. I'm just going to make up a different one. What would I do if I gave you this figure? All right, what would you do to solve for x if I just gave you this? If I told you this is 3x and this is 5x and the perimeter is 72, what would you do to solve for x?
3x plus 5x equals 72.
Close. So Yurat said 3x plus 5x equals 72, and she's close.
8x?
That's 3x plus 5x. So that's also very close. How many sides does this figure have? 4. So you're only taking into account how many of those sides? 2. So what do you need to do? Double it all, basically, right? If this is 3x, what's this? And if this is 5x, what's this? Okay, so then all together, what would that be? So 3 plus 3 is, 5 plus 5 is, 10 plus 6 is, and then how would I finish? Divide by 16. Very good. All right, which ends up giving us 4.5. Could you find the missing sides then? How? Plug it in. Yep, plug it in. What if I told you area equals 450? Then what would you do?
That would be 3x plus 5x. 450.
Close again. if we were talking about perimeter still, but now we're talking about area, and how do you find area of a rectangle? Multiply. So instead of doing 3x plus 5x here, what would you do? 3x times 5x equals 450. And what's 3x times 5x? 15x squared equals 450. Good. Okay, now what? Divide by 15. What do I have left on this side? X squared equals, and then 15 goes into 45 how many times? 3. So this would be 30. How would I finish this? Don't overcomplicate it. We're not going to factor. We don't have to factor. Just take the square root. So square root. So x equals the square root of 30. And that's it. And the reason I don't simplify it anymore is because 30 is not a what? Perfect square. So I'm done. I don't have anything else to do. Okay, so x is the square root of 30. So what was the difference between this one and this one? Maybe a little more complicated, but what kind of arithmetic do we do here? Adding, and what do we do here? Multiplying. Okay, so the difference is that you plug it into the formula you know. For perimeter, we add. For area, we multiply. Okay, so for your practice, I just want you to try 1, where you're going to try to find x, and then also AD and BC, and then 4, where you're just finding the area. Okay? All right, go to your boards, try these 2. Okay, so with this second one, number 4, I saw everybody set it up like this. Area, not everybody, but most people set it up like this. 28 times 20 divided by 2, and then you did 560 divided by 2, which is totally fine. Gives you the right answer, which ended up being 280. But if you look at it like this, half of 20 times 28, what's half of 20? 10 times 28, what's 10 times 28? 280. That might be just a little easier to do mentally. So again, just because it's a fraction here doesn't mean it needs to be harder, because half of anything is just that number divided by 2. All right, so these both give you the same answer. Either one is correct, whatever way you want to do it. Okay, so triangles, squares, and rectangles work like that. What's the difference between a circle and the other ones we just talked about? Yes. No edges. It has no edges, so therefore it does not have a perimeter. So Madeline, what does it have? Okay, circumference is just basically the same thing as perimeter except with a circle because it has no edges. What is the diameter of a circle? The whole thing, the line all the way across the middle. So we would say this is the center, maybe-ish, and the diameter goes all the way across. All right, so that's the diameter. All right, and then the radius does what? Goes halfway. So a radius goes halfway. The area is still all the stuff inside, and the circumference then is all the stuff outside. So all the way around the edge. So circumference is similar to perimeter. But yeah, the formula is a little bit different because we cannot use edges. There aren't edges, so it's not like you can just add up all the sides of a circle because there are no sides of a circle. So the formulas for circumference and area, to find the circumference of a circle, pi times diameter, or pi times 2r. What's 2r? The radius times 2. How come it can be either of these things? The diameter is the same thing as 2 radii. Okay? Yeah. No, you're probably thinking once we get to like sector area and volume. So hold that thought for like 8 months. All right? Just file that away for 8 months. Okay. I will be back with 2 kids by the time we get to that, but you will need it. Okay, so what's pi?
3.145.
Yeah, great. But what is it?
Infinity.
Okay. What is it, though? Where does it come from? Okay, it has to do with circles. So basically, a long, long time ago, all right, somebody, again, this is like pre-Netflix, pre-social media, when people didn't have things to do on their phones, so they had to do math problems for fun, which some of us still do, but most of you don't. But what somebody figured out is basically, if I take, let's go back here. If I take a circle, and this diameter is a string that goes through the center of that circle. If I take that string, I can wrap it around the circle 3 times, and then there's a little bit left over. And that number, that ratio will work every time. If the circle's this small and the diameter goes across it, 3 of those strings will fit around the circle with a little bit more, and it will always work in that ratio. And that 3 and a little more is pi. Okay, so we use what for pi? 3.14. Is that exactly pi? No, because like Martin said, it goes on forever, right? So pi goes on forever, but what that is the number of diameters it would take to wrap around a circle. So again, imagine this is a string, and you're wrapping it around this circle. There would be 3 of them, and then you need a little bit more. And that's what pi is. So that's why when you see any equation with circles, that's why you need pi. That's where it comes from. That's why we have pi, because it's the number of diameters that it would take to wrap around the circle. So the area equation then is, does anyone know? Pi times r squared. Pi times radius squared. All right, so the area equation is pi times r squared. And what is squared? Multiplied times itself. Not times 2, but times itself. Unless itself is 2. But yes. All right, so how would you find the circumference of this? Circumference of this. Go back to the formulas. Well, before we go back to the formula, is this a radius or a diameter? Radius. So then do I want to use the top equation or the bottom one? Bottom one, because we have the radius. So we're going to do pi times 2r, where r is what? 12. So pi times 2 times 12. Now, here's where I tell you the good news. In my class, you can always write things in terms of pi. And what that means is you don't actually have to multiply it by 3.14. Just leave the pi symbol. So what's 2 times 12? So I'm just going to write my answer as 24 pi. And that's it. You could, yeah. Like if you want to, you could do 24 times 3.14. But is that an exact answer anyway? No? So to me, this is simpler, and it's still, like either way, it's not going to be exact. So I'd rather leave it here. You don't have to. If you want to multiply it by 3.14, if you want to get a calculator and do the pi button and multiply it that way, fine, by all means. I like answers like this because I think they look cleaner. But you do it however you want to do it. So this is called in terms of pi.
Do you have to put centimeters, or like if it's...
The age-old question. Considering I have forgotten every single time to write my units, I do not penalize when people do not write units. I should be a stickler for it. I'm not. It's just, I don't know. I don't care. But if you were to do it, you would put a little centimeter. I should not put that on YouTube. I care so much about the units, but I don't. I always forget my units, so if you forget them, that's fine. Okay? The only difference is if it's area, it would be centimeters to the second power. Yep. Okay, what would be the area of this circle? So let's go back. What's our formula for area? Pi times radius squared. So I'm going to do pi times r squared. What's r? So pi times 12 squared. What's 12 squared? So my answer is 144 pi centimeters squared. All right. You do not square pi, though, just the radius. All right, so 144 pi. Again, if you multiplied that out, you would get something like 420 something. All right, 420 point something. It's okay if you don't. You can leave it like this. However you want to do it. If you're not comfortable leaving it with pi, then multiply it by 3.14. I just like less work. All right, Any questions? Okay. We are, I know you're going to be mad